Hi, my name is Norman. Feels great to be back again. Please, dog, would you please stop it? He's right under the tripod. I don't know for what. Come up here. Come, say hello. He's in a very cuddly mood at the moment. I got a new project, right there at the side. Let me just tilt over here. There it is. I am printing a new 3D printer. This is somewhat a bigger project. It will probably take a couple of months because it's a lot of printing time. So yeah, I'm going to take my time, but printing a 3D printer is not so easy because usually you print with PLA. It's safe, it's simple, and basically, stop it. Basically, when you want to print a 3D printer, you need to use harder materials because PLA is obviously not hard enough. And that's why I chose to go with ASA. Usually you'd use ABS for this type of prints, for printed 3D printers. ABS is the material which is used for Victorinox knives, the plastic scales, or also Lego bricks, of course. So this is a very common material. But I chose to go with ASA because it's basically better in every way. So it's a little bit harder, a little bit better with pressure, tension, chemical resistance, weather resistance, everything. I looked it up, it's better in every way. That's why I went with ASA. Still, ASA has a lot of warping compared to PLA. It's supposed to have less than ABS though. That's why you can see this. To prevent warping, I need to, well, have a more or less stable temperature around the printer. That's why I built up a makeshift enclosure. The lid is really cool. This is not only a fire hazard, it also looks really ugly, and we don't want that here in my office. IKEA has a line, the Stuva line. It's perfect for this one, for this cupboard thing, because it has a 50 centimeter depth. Unfortunately, the line is discontinued, and the simple box which I wanted to have is unfortunately not available anymore. We are makers, so we're gonna make it ourselves. The only thing which is funny enough, which is not discontinued, is the front part. So basically, this is something we can use. I'm going to go to IKEA and get it one day. For now, we're gonna start with the base housing and, you know, build it so that we don't need to use this. What is this? So as smart as I am, of course, I thought, well, let's just CAD this thing, because then I don't need to measure or calculate any measurements for this enclosure. So I knew that the front was 60 by 60 centimeters. So each side here, you can see down below the bottom, it's 600 millimeters. And I knew the wood I was going to buy would be 18 millimeters thick. So I just drew these, you know, rectangles or boxes, and here we are now. So I just can take these measurements here, for example, take it and write it on a piece of paper, and then we would be good to go. You can actually go down to the hardware store, and most of them offer a cutting service nowadays, so you can just go there, tell them what you need. Oh, my printer's done. Cool. And they're gonna cut the piece of wood exactly the size you want. Bad thing is, if you have wrong measurements, gotta take out the big guns and make them cut yourselves. Because for some reason I measured 48 and I entered 58 into the program. So yeah, we gotta cut off 10 centimeters of those sheets. This is the size which is too long, and we're gonna cut it down. But before we go outside, this is the part which just, you know, finished. And let me just show you a quick, neat little trick. You can see here the white surface. This is where it's stuck to the build plate. This is something you commonly get in plastics when they are under stress. Another example where those white surfaces appear is where support is. This is a foot of, you know, this monkey here. Yeah, this is where the support was. And these white surfaces appear everywhere where the plastic was under stress, and it's very easy to get rid of them. You just take a lighter and heat up the surface. You know, it's a little bit easier with black. It's a lot easier to do with black material because the flame, you know, it blackens the material, but it doesn't matter with black, of course. But if you're using lighter colors, of course you gotta be a little bit more careful about it. But as you can see here, no more white surfaces. Same here. I'm gonna show you up close. Do you see how it vanishes? Also, as you can tell, this here is ASA. It's a little bit more heat resistant. That's why it needs a little bit more heat to get rid of the white stuff. But it's almost gone. The monkey foot is PLA and a lot easier to heat treat. That's it. And you can see it's warped. It's because this bottom side is hotter than the top side because, you know, it just heated up with a lighter. And yeah, but it's gonna unwarp once it's cooled down again. So no worries. Small parts tend to warp less than large parts. So I'm going to print small parts until I have, you know, finished this project here. I tried to print a larger part and I got a lot of spaghetti. I tried printing using a draft shield. This is basically the printer prints around the perimeter to build a enclosure, but that wasn't enough. Nevertheless, you can see very, very well here how much is it bent. I'm just gonna align it with the line here. I think it's more than obvious, the bend, the warp. If it warps too much, like here, this entire thing is going to come loose of the build plate. And of course you don't want this to happen during a print, you know, for obvious reasons. Yeah, we're gonna build this enclosure so that the entire part is going to stay warm and don't have too many temperature differences within the part, if that makes any sense. So now you learned again a little bit about 3D printing. It does get complicated once in a while, and this is definitely one of the cases in my opinion, because, you know, it could be so simple, but apparently it is not. So let's go outside and do these cuts. So here they are. This is scrap, this is the real thing. I also cleaned up the edges of the scrap wood because, well, nobody wants to get injured and get some splinters in their hands. I'm going to keep those. Maybe I'll make something with those. It's always good to have a little bit of scrap wood. There are a couple of restaurants right in front of my balcony, so the smell of schnitzel gently reminds me that lunch break is over now. Gotta walk the dog and then I gotta go back to work. You know, it's just stay at home office thing. I'm gonna bring these things inside, then see you guys this evening again. Well, I was wondering if you were wondering why I actually do have so many pieces for just a single box. The answer is because I have two printers. So I'm gonna build two boxes. So yeah, now that question is answered, I hope. We do have two long ones and two short pieces. The long ones are going to be top and bottom, and the short ones are going to be the sides. This is the biggest piece and this is going to be the back side. Well, when assembling these types of boxes, there's only one thing you need to worry about, which are the corners. Because right here, you're gonna have like 3 screws. Great. Because right here, you're going to have 3 screws. One coming from here, one from here, and the other from here. So you gotta think about 2 things. Number 1, not having your screws interfering with each other. And number 2, not having your screws too close to each other. For example, if I drill here a hole and right next to it another hole to fix these two, to fix this one and this one to the bottom, that would be too close to each other. Probably I will start off with attaching the sides only, so this one is going to come later. The width of these screws is 5mm and the length is 50mm. So I'm going to take 60mm from the edge. That's going to give me enough space so that the screw will fit in later and they won't interfere with each other. Just for safety, I'm going to add a third screw in the middle. This is like almost 48 centimeters. So I'm going to take 24, which is right here. And because the thickness of these is 18mm, I'm going to take 9mm from the edge. And now we got a cross. So, of course, do the marking also on the other side. 6 centimeters here, 24. If we learned one thing, then it is that I'm not very good at measuring. Usually, you could measure from the outside 6, 24, and again 6. But of course, this is not going to work. So I'm just going to try to hold this thing here to the holes and then drill a hole, you know, pre-drill this piece of wood as well. And because nobody is going to win the fight against gravity, I'm going to tilt everything. I don't have a square, so I'm going to use this 3D printed box, which is for obvious reasons not in use. That's going to do just fine. So, and because, well, these holes are more or less custom fit to each other, I'm going to make some marks so that I know which edge belongs to which one. So this is edge number 1, edge number 1. So this one I can flip around, this one need to replace. There you go. Different piece, same thing. This is the wrong piece. So, it's time to fit those pieces together, and I'm pretty certain they won't fit. The back piece probably won't fit in between those two side panels, but soon enough we're gonna find out. I'm going to turn on the torque limiter so that, you know, it stops when I apply too much torque, but I don't know how much is too much actually. Let's just go to 5, whatever unit that is. Okay, 5 is not enough. 10. Yeah, feels great. I'm sorry, I did run out of memory. Midway, I just installed the last screw. Actually, now, before I install the other side panel, I'm going to install the back because, well, this is here a lot of leverage and I can easily break out those screws. So once we got this triangle pyramid shape, this is going to be a lot more stable and I shouldn't be able to break it accidentally. I think for the sides, I'm going to make the exact same procedure. So one here, one in the middle and one here. I know, bad camera angle. Let me just move that around. So you're good? You're good. So I think I will install those screws first and then drill the last hole because this is this is messy right now. Guys, I think you got the basic idea how this thing works. So I'm going to finish both of those boxes, drill the holes, do the thing, then I'll be back, okay? So we got both of those boxes ready, but of course we aren't done yet by far. The next 2 steps will be getting power and lighting inside. So power is actually a fairly simple solution. For that I bought 2 of those power strips. Those were basically the cheapest one I could find. Of course, because they are budget power strips, they have absolutely no way to mount anywhere. Coincidentally, I printed out these things. I designed them and I'm really happy that I actually got all those curves here on the outside perfect so that you know, these brackets fit around the power adapter and are ready to be mounted on the inside somewhere. I don't know yet. To get the current from the wall outlet to this power strip here, of course we all got that cable, and that cable needs to go somewhere through the back side of this. And for that, I just bought these premium hole saws. I think they're called that way. You put them on a drill and then it spins, what the drill does probably, and then you got a hole. To cover everything up, I got those. I actually got them ages ago, and you can see, yeah, this is what you get when you have a dog. He doesn't chew on things anymore, but he did that when I got him very early because he was so nervous, and when I left the house he thought I'd never come back, so he got nervous and chewed on things he found, and these things were one of those. That's why I never installed them. But I think for this box they will do. Yeah, order of operations: drill a hole, mount them, mount that. Okay, literally 2 seconds after drilling the first hole, I realized there's no way I'm going to use these. Not only because, well, it doesn't really fit down there below, also because, well, the hole diameter is exactly the distance between these two holes. So yeah, there's no way to fix them here. I think I'm going to salvage this brush thingy here, but I'm going to print one of those sooner or later, so that, you know, we have a nice cover in the back. Looks a little bit cleaner. Yeah. So now for the lighting, we have a very, very specific problem. Let me show you. I've got this torchlight here, and well, if we put one light on top of the printer, you can see, or maybe not see, here on the build plate. You can see here on the build plate, wherever you put the light, this thing on top, or the X carriage, is going to cast a huge shadow. So you won't have any light there and probably can't see where you're working at. To solve this, you could either move your light source to the front and you're gonna cast a shadow yourself, or you're gonna make one huge light source, which is hopefully going to solve my problem here, so that, you know, every point does get a little bit of light. You'll get that in a minute. So, how do you make a huge light source, you may ask? Well, I could make some of those. So this is the lamp which I'm using for filming to, you know, light myself, so that you can see me and my face. This is a thing which I would love to have on top of my printer because it makes amazing light. But unfortunately, obviously, it's a little bit big, so we can't use that. Instead, we are going to use a solution like here, which is a lot of LED strips which act together as one big light strip. So as a base, I'm going to use this light strip here. I think this is 150 centimeters. And yeah, I'm going to use one of those for each panel. And these things actually also do have motion control, which you plug in here, but we are not going to use that. We are going to make something like a square to spread the light sources across the surface. Just gonna unplug the controller, and then we are going to make 30 centimeter pieces. 1, 2, 3. And for the last one, I think we are going to make 3 individual for a smaller center light. If that makes any sense, I don't know. I'm just trying to spread those LEDs as much as I can. So we're going to have one here, another one here, another one here. Just imagine a square, and then you know, 3 in the center, like so. Doesn't look like much, but I promise it will. Okay, so I stripped off the isolation, or what is it, this rubber coating cover, and then I pre-soldered the connections here. Trust me, it's going to be a lot easier to attach wires to a pre-soldered strip than vice versa. I am going to use these hard wires. So there are soft wires available, which are very, well, soft, I guess. And they consist of copper wires, and a lot of them inside. I don't know the term for it, but that's what makes them so flexible. Instead, I'm going to use some cheaper, I think it's aluminum But the main difference is that they just have one single strand inside. Yeah, they are less flexible, and that is going to help me to you know, lay out the angles which we are going to have later. And also, because there's just one single strand and not multiple little strands, I'm going to be a lot less likely to you know, mess up the connections here. One strand goes to one end and nothing else. So I'm going to wire strip the ends, just one side of those, because I'm going to attach them first, solder them first, then I'm going to make the bend, the 90-degree angle, and then I'm going to cut them and strip the other end of these. I'm going to make a 90-degree angle. So just gonna bend one after another. I think it works better than trying to bend all at once. So here we are, 90 degrees. I'm grabbing them all at once with the pliers. That's to make sure not to grab to add stress to the soldering. Very carefully. Just try to grab the isolation, plastic wrapping. Of course, it doesn't work. First refract them, let's go that way. So you gotta be very careful not to cut off the wires, otherwise you gotta redo the entire thing. So just make sure you're very gentle. And let's do one by one. There you are. So I'm going to repeat this off camera because it's really hard to do it in front up there. I really don't want to mess this up. And the first one is the hardest, but once you've got the first one in place, the other one's gonna be a lot easier because it's going to hold itself together to a certain degree at least. And then guys, what did you think? That we're gonna make a video without hot glue? That's where you're wrong. Of course we're gonna use hot glue to secure everything and yeah, also seal it more or less from the environment. For some reason I think it's just better. As always. Doesn't look as nice anymore probably, but you know, it's gonna work. So I'm going to repeat these steps for every connection here, and once I'm done, hopefully everything is going to work as planned. As you can tell, it's already making plenty of light, right? So here, these are going to be attached to the top, so you gotta imagine it's upside down. So that surface is bright. That's the point of this whole operation here. But as always, there's room for improvement. So I thought maybe if I add some reflectors, I could increase the brightness. I don't know if it's visible on camera. It's even barely visible in real life, but I think, you know, it just makes sense. If you guide those stray photons back to where they're supposed to be, it should be brighter, right? So that's science, I guess. Yeah, of course, having a piece of tinfoil up there isn't very practical. So I printed a couple of those, and by a couple, I mean 32. Only going to use 28, so. But those are 32, 40 hours of print time, 48 hours of print time combined. Yeah, it's like a U shape. And I will spray paint these surfaces here with reflective chrome spray paint, and hopefully this will increase the brightness of these strips. Well, I anticipate it not to be very helpful to increase the brightness tremendously. I hope that at least it's gonna be a little bit nicer, look a little bit cleaner, and that's also a very nice benefit. First, I gotta prepare all those parts here. You can see, okay, this one is fine. You can see here there are some printing issues, so gotta remove that. Very simple, but I gotta do this with all those parts here. But yeah, it's gotta be worth it, hopefully. So much effort for such a small detail, which probably nobody's ever going to notice. However, primer is currently drying outside. Yeah, once it's dried, we can apply this chrome spray. I hope it's going to give me the desired effect. And while the primer is drying outside, we can actually have a look at those doors. Those two. I went with 60 by 60 because I knew IKEA had these 60 by 60 doors, and I stuck to IKEA because there's no place like IKEA where you can get real glass wooden frame doors which are only a little bit bent. Okay, that's weird. But you know, that's like the cheapest place to get glass doors, at least what I could find. So this one was just like 15 euros. So it's a very reasonable price, and also assembly should be a bliss because most of those parts fit together perfectly. So I can get a door, 2 soft closing hinges, a pair is like 10 euros, closes, and then you can see it closes softly. So to get them installed, I'm first going to install them onto the door, and then I'm going to grow another pair of hands probably and hold the door right next where I should go and screw it down. Yeah, actually should be simple, right? I'm going to use these papers which were included with the door as a shim so that, you know, it's a little bit off the ground. Okay, I'm going to unfold them. That should do the trick. Yeah, I'm just gonna use a hammer to mark. Try to get it as parallel as possible, the door and the wall. Okay, so from the outside it's 4 centimeters. Okay, also a very small detail. Here I'm using a 3mm drill bit, wooden drill bit, for a, what I believe is a 4mm screw, I don't know. That screw needs a little bit material which it can bite into, let's call it that way. So I don't want to make that hole too big. And because that's very soft wood here, I can use a 3mm hole for a larger screw. Also, you've seen it already, I added a little bit of tape here. That's just because I know that this one is 18mm, so I made a marking from the tip of the drill bit to be exactly 15mm. So this is also the depth of the screw here, and it prevents me to drill through the entire thing. No holes on the other side. Okay, so spraying is done. As you can tell, we got a little bit of bleeding here under the masking tape. Also sometimes here, for example, on the outside. But also, as you can tell, it does not reflect as much as I was hoping for, as much as, for example, this lid is actually promising. So that's kind of a bummer. If for any reason you come over here and you see those lights in future, just act like you're surprised and say, oh, how did you get these lights so bright? Because that has been a lot of work. Whatever, we are going to attach those here on the inside, of course. And for that we are going to flip the entire thing, which should be fairly simple, a simple task. So we're on the final stretch, everyone. Last thing we need to add are those things. These are actually thermometers for I don't know what, but they were fairly cheap. 5 pieces, 20 euros or something. So you can see here, maybe you can see it, maybe not. The big number is humidity and the small number is temperature. Actually, we are more interested in temperature, but still, it's not too bad to also know the humidity inside the chamber. So that's pretty cool. So unfortunately I didn't have the right size for the hole saw, so I took the bigger one because yeah, with this material it's a lot easier to fill in small gaps than taking away small gaps with without a lot of manual work. So yeah, I took the easy route, and to be honest, it looks a lot worse on the inside. Just how do I... So, to be honest, it looks a lot worse on the inside, so maybe I need to print a cover one day, which is going to, you know, still let in the air for the sensors inside, but cover up this ugly. But before we install these puppies here, yeah, I got some good news. Couldn't resist printing those things. So these are going to be the back covers for that little hole here in the back. Should be the same fit as the original piece, except that I have holes on the far outside. It's going to make them fit. There you go. Okay, as you can see, one of them is already operational. I had to do some tweaks. Well, these standard issue spool holders for the filament, which go to the side of the printer, actually couldn't fit because, well, it's a very, very tight space. So I designed and printed a simple hook which holds the filament spool up there. Very, very simple, just wall mounted. There we go. Also, I tried to make use of that motion sensor. So the basic idea was that, you know, the light is constantly off, and whenever somebody wants to check out the printer, you know, it should turn on. I don't know why it's not working very well. So this light is just permanently on. But let me show you on the other one. It's not working. One thing is, maybe I'm just having trouble dialing in the sensitivity. The other thing, maybe you know, the infrared sensor here has trouble penetrating the glass. So I don't know what's the issue, but basically it's not really working. It's just sort of working because you need to open the door, then the light turns on, which is, yeah, a little bit good, I guess. But since it was more or less free because I had these lying around, and actually also my mom paid for those, I didn't pay for them. So they were really free. Yeah, it's really nice to have this automatic light up feature. You can see timer is 30 seconds. Once I move the door, it's gonna open. So right now we have 29.8 degrees Celsius inside this chamber. Usually, especially for very long prints, it settles around, I guess 33 was the highest I got. So it's cozy, warm. Yeah, here is proof of concept that it works. You remember, and at the beginning of the video I showed you a pile of spaghetti. It got loose of the build plate because it warped too much, so yeah, I wasn't able to complete the print. But now with a chamber I got steady surrounding temperature, probably also a little bit warmer than outside. Both of that helps to prevent warping, and as you can see we have almost zero warping. So it is still a little bit, but it wasn't enough for the print to get loose. So that's some really great news. Now I can print the larger parts for the new 3D printer. Let's hope that one day I will finish that project and it's not going to end up like, you know, yeah, I hate that project because, you know, you make one mistake and it's gonna cost you 300 euros. So yeah, I need space. Right now I don't feel like finishing it. Yeah, proof of concept, it works. That's great. Dog is also saying hello. Come on, come here, come on. So yeah, that's it. I hope you learned something. Thanks for watching. I hope you enjoyed it. Yeah, this is YouTube. You know how it works. So see you guys in the next one. Bye bye.